Welcome to Vet Fraternity. In this video series, we are going to start Canine and Feline Endocrinology for the NAVLE. This is going to be the introductory lecture. And in the introductory lecture, let's see the topics that we are going to cover in the endocrinology. Diabetes mellitus, diabetic ketoacidosis, hyperosmolar hyperglycemia, acromegaly, hyperthyroidism, hypothyroidism, hypoadrenocorticism, hyperadrenocorticism, and pheocytochroma. These are all the topics that are very important for the paper point of view. So, first thing you are going to see in the manual that I have made is a signalement of the diseases. Uh, from paper point of view, the first part of the MCQ that are given to you is the signalement of the animal, and this signalement is very important. I'm not going to break down or go into the detail of the signalement right now, because this is the same signalement that we are going to see one by one when we are going to study the disease. So in this lecture, I'm just going to focus on some hormonal physiology that you must know before we begin with the diseases of the hormones. The four basic hormones that you must know are cortisol, thyroid, insulin, and glucagon. These all hormones majorly function on three different organs. On the liver, that has its role related to glucose, and number two is adipose tissue or the fat, and number third is skeletal muscle or the protein and the amino acids. If you see the cortisol acts on the liver, and it starts the formation of gluconeogenesis, that is the production of glucose. So hyperglycemia will happen with this. As far as its effects on adipose tissue, it will cause lipolysis, that is breakdown of lipid, and it will decrease lipogenesis, that is reduced manufacturing or like production of the lipid in the body. And because of this breakdown of lipid, the concerns that happen, that the fat redistribution in the body starts to happen, and you might see animals having pot belly. That means they are going to have a pendulous belly type situation, which is one of the characteristic. Then cortisol effect on skeletal muscle is that it decreases the protein synthesis, and it increases the protein breakdown, because when the protein will break down, it will produce amino acids, and these amino acids are the ones that are going to be used in this gluconeogenesis process. Because gluconeogenesis is a process which means that production of glucose from molecules other than carbohydrate, that is amino acids or lipids. So the amino acids, protein breakdown into amino acids, and these amino acids are utilized by the liver to produce the glucose. Number two we have is thyroid gland. Thyroid gland is called as calorigenic gland. Thyroid hormone that is produced from thyroid gland. It's called calorigenic because it has its role related to basal metabolic rate, and it functions on those calories and everything like that. Its effect on liver is that it causes increased glycogen formation. It increases glucose uptake into the adipose tissue or muscle. That is, this it means it lowers the level of like glucose in the bloodstream, and it increases the glycogen, the storage form of glucose. Like it shifts the glucose from the blood to the glycogen form. Then effect on adipose tissue is increased lipolysis, and it is a catabolic process. Catabolic means the breakdown process, that it causes the breakdown of the fat. And as far as protein, it increases the protein synthesis. Next we have is insulin, which is a very important hormone. It is called as anabolic hormone. Unlike just like the thyroid was a catabolic, insulin is an anabolic hormone. It decreases gluconeogenesis. It increases glycogen synthesis, and it increases glucose utilization. Basically, what happens, it basically tries that the glucose that is in the blood, it should be utilized by the body. So it can be utilized in form of like glucose is then transferred into glycogen form, or gluconeogenesis is reduced. Like the production of glucose, those processes start to decrease, and the utilization of glucose in the different body cells starts to increase. So overall net effect is hypoglycemia. And it also decreases the ketogenesis. Ketogenesis, basically, we are going to see its detail when we will study the diabetes. But basically, ketones form when there is like when body is unable to utilize the glucose. So what happens? Ketones start to form when glucose is being utilized. Then ketogenesis, the process of ketogenesis gets decreased. Effect on adipose tissue is that it increases glucose uptake, it increases the fat synthesis, and like that means increases lipogenesis, but it decreases lipolysis. Then we have skeletal muscle or protein. It increases the protein synthesis, it decreases proteolysis, it is anabolic for the protein. As far as glucagon is concerned, that is the opposite hormone of insulin. It has all of its effect reversed to insulin. That is, increased glucogenolysis, increased gluconeogenesis, increased lipolysis, increased ketogenesis, increased proteolysis, that is, increased production of amino acids. So that was all about normal physiology of hormones in the body, how they work on these three body organs, and you should have a good concept of these things before you jump into the diseases. So in the next video, we are going to start the diabetes mellitus. Thank you so much.